Good evening, everyone. A warm welcome to all of you to another session of our industry-oriented training on Python programming for AI and data analytics. Over the past few sessions, we have explored NumPy's powerful capabilities from working with arrays and mathematical functions to performing matrix operations and linear algebra. Today, we bring these concepts together in a practical session on numerical computing, where we will apply what we have learned to solve real-world scientific and engineering problems. Today's hands-on session will focus on real-world scientific and engineering computations using Python and NumPy. You will gain practical experience in implementing numerical solutions, performing research, data science, and artificial intelligence. This session is an opportunity to see how mathematical concepts translate into practical applications through programming. I encourage everyone to code along, explore the examples, and actively participate throughout the session. Practical implementation is the key to building confidence and developing strong problem-solving skills. It is my pleasure to welcome our esteemed mentor and speaker, Dr. Meherchand, Associate Professor at Babarit College of Engineering and Technology, Bhatinda. With his extensive expertise in artificial intelligence, machine learning, computation sciences, and Python programming, he continues to provide real-world challenges. With great pleasure, I invite Dr. Meherchand to kindly lead us into today's practical session. Over to you, sir.
Thanks, dear Face, for the nice introduction. And good evening, all of the participants. Today, we are going to cover two files. Okay, one is completely based on NumPy. So, NumPy based operations we have discussed in the previous sessions. So, this file I will provide you to cover yourself. If there, I think there will be no challenge, no problem. Only the some new engineering problems are there. Okay, but the second file which I will cover here during the session, that include two most important libraries. One is the symbolic mathematics, and other is SymPy. Okay, SciPy, sorry. Okay, SciPy and SymPy both are very powerful libraries for the scientific computing, and SciPy is the open source library built in NumPy that provides advanced mathematical, scientific, and engineering functions. Okay, and is widely used for the numerical computing, optimization, statistics, signal processing, image processing, interpolation, integration, linear algebra, and solving differential equations. So all these components, the topic which right now I mentioned, highly useful in machine learning, deep learning, data science. Okay, and including the scientific computing. Sometimes, if you are working on the other branch of the sciences or engineering problem, so SciPy play very important role because uh, all the things which you are required for scientific computing, you can do easily by using this tool. Okay, which is a specific library. Okay, and SciPy offers a comprehensive collection of the modules that simplify the complex scientific computation, making it essential tools for researchers, engineers, data scientists, and students. Its seamless integration with the libraries such as NumPy, which we have covered in the previous session, Matplotlib we are going to cover in the coming session, Pandas also we have covered. Okay, enables efficient data analysis, visualization, and computing modeling. Okay, so this is all about the detail of this is SciPy, which we will cover during the you can say by using Jupyter notebook. Okay, and there is other library which is SymPy. Okay, SymPy is the combination of symbolic mathematics and Python. Okay, so by using symbolic mathematics, by using this SymPy, all type of the symbolic computing, which is the part of symbolic mathematics. Okay, sometimes just like we are required exact solution. Sometimes if you are using the approximate value, okay, so approximate just like if in the place of x is equal to, you have under root 2, square root 2, okay, but in the place of square root 2 you are using x is equal to some approximate value just like 1 point something. So this approximate value, when we have the lot of iterations, we have some error in the exact solution and the approximate solution, because this will provide us approximate solution. And when we need the exact solution, in that case we have to use symbolic expressions, okay. And sometimes when you solve any differential equation, whether it is a partial or ODE, so the solution will be, we have some function. Okay, so this type of the calculations we are not able to solve by using the other libraries, just like NumPy, because NumPy is completely based on numbers. So when we have any continuous function and you want to operate some any function just like integration, derivative, limit, etc. So these are not we are not able to apply by using the NumPy. We have for that SymPy. SymPy play very important role. So for this SymPy, I think my screen is visible to all of you. Yeah, is it clear? So
Yes, it is
before
clear.
using, yeah, thank you. Before using the SymPy, during this session, I will not be able to cover all the concept of the SymPy, but I will give you some demonstration. Okay, so uh, this document which I will demonstrate right now, all the examples are there with their code. Okay, and see what you will do. You will write here SymPy, sympy.org. You can see this URL sympy.org. Okay, also I will share with you this in the WhatsApp group. You can access the URL from that place also. This is the my WhatsApp group. Okay, so here I am sharing the link. So when you will click on the link, you can easily come to this one. Okay, so now SymPy. Okay, where I was using. Yes, okay. So you can see this is the sympy.org. When you will click on it, just what you need to use only, you are required to spend only 1 hour on this document for all type of the operations which you are required. Okay, so see after that this is the official website of sympy.org, and come to the documentation. Okay, so all the information why SymPy is essential, project using the SymPy, all the information are there, and all these packages which you can see here are different applications on all type of the all basic sciences. Okay, just like you can see come to from the CamPy, which is used for chemistry. Then you can see Einstein Pi, package for the symbolic and numerical general relativity. Okay, so you can go to all these detail, but you are required to come here documentation. So when you will click on the documentation, you will come to at this page. Okay, so after that you will click on the tutorials. When you will click on the tutorials, and okay, here is introductory tutorial. When you will click on the introductory tutorial, you will come to at this place. Okay, so here you can see all the topics, and mainly I will concern here just like calculus, solver, matrices you have already covered in the previous session. Okay, by using SymPy also we can do all the operations which you have covered by using NumPy. Okay, but this is very beautiful and easy to use library, and you will enjoy this um, library. Okay, so just I want to present some few examples so that you will realize the importance of the power of the computing. Okay, so just like in the calculus we are covering derivative, partial derivative, okay, integration, limit, asymptotes, etc. So here you can see this is starting from the derivative. Okay, I am not going to cover the concept of the basic fundamentals. Okay, just I let you how you can use this library, because I assume that all the fundamentals of all the participant you have studied, just like derivative, integration, limit, uh, just like polynomials, okay, solution of the polynomials, quadratic equations, cubic equation, okay, and many more. So how you can see this, just like this is the
No, we can't hear you. I can't hear you.
hello, hello,
Hello,
Hello?
sir.
I am audible.
Can you?
Yeah,
Yes,
you are audible.
yes, sir.
Okay, thank you. Sorry for the interruption due to fluctuation in the electricity. My system shut down. Okay, so I was talking about, just 1 minute. I going to share my screen. Okay. Uh, yes. So I was talking about this file. If there is any interruption from his side, please let me know. Okay. Uh, okay. So here you can see this is the calculus. So how you can use
Will
this
you
file?
repeat?
My
Will
voice
you
is clear.
repeat once? Yeah. Will you repeat once?
uh, yeah, derivatives. Okay, so I want to know my voice is clear to all of you.
Repeat the steps.
I am asking, I am audible? Okay,
Yes,
re-
audible.
audible. Okay, see, see here, this is the document file. I can repeat again this part. So what you will do, you will come here, simpy. This is the simpy.org. Okay, So this official website will open, and the link of this SimPy I have shared in the WhatsApp group. Okay, you will come to here documentation. This is the documentation. You will, when you will click, then you can see here tutorial. Okay, when you will come to this page, then come to here introductory tutorial. Click on it, and this introductory tutorial will open. Also, this page link also I am sharing in the WhatsApp group. So easily you, when you will click on it, you will jump to this page directly. Yes, you can see. Okay, now here you can see various topics are there, and you are required to spend here 1 to 2 hours. And specifically SimPy features, here you can see I am going to talk about this part, calculus. Okay, so you can cover printing or basic operation, simplification. Okay, but partially we I am going to start from this place. When you will click on the calculus, here we have the derivative, partial derivative, how you can use them. Okay, so various examples are there. Okay, so what you can do along with the this is the example. Okay, so when we will use this SimPy, you will import a SimPy by using this statement: import SimPy. So from SimPy import product sign. Okay, so the meaning of this sign is to import all the functions which are based on SimPy, and after that you are required to use some defined variables. Okay, just like we are using xyz, and in the case of symbolic mathematics, or you want to write any function variables, or you want to differentiate, you are required some variable. So according to your need, you can define the variables, just like by saying this statement, we have xyz is equal to symbols xyz. Okay, so in this way you can define the variables. After that we can take this example. Okay, and various examples are there, along with how you can use without using any uh, interface of the Python. Just like this SimPy, we have one live SimPy. Live SimPy, live.SimPy, you can see here. This is the URL, live. This is the URL, live.simpy.org. So when you will click on it, this live shell will open. The link of this one also I am sharing with you in the WhatsApp group. Okay, this is the WhatsApp. So both the shell I have shared with you. Okay, see the importance of this one. So when you will open this one, keep carefully this statement on the top, which you can see, a web assembly powered Python kernel packed by Pyodite. So when this statement will appear, only then you can start to work on it. Because when you will open the shell, this will take a few seconds. Also, this URL you can open your mobile. Okay, so as your mobile, you can use as a tool. Just you are required to open this link in your mobile. Okay, so all the operations which we will perform you can do easily, but only the difficulty to give the input statement. Okay, but you can do. If you are using the system, then this will be very quite easy. Okay, so when you will open this live.simpy.org, this statement will be automatically appeared there. So you can see this statement which I shown you in the previous link here. Okay, and this statement is also there, which you can see here. That is also added place from simpy import this one. So this is the way when you can install in your system. If you are required to install, you are required to use this library. Okay, but along with the Anaconda, when you install the Jupyter notebook, all type of this library which are essential are there. But when you are using basic Python, so in that case we have to install this library, and then after we can use. And here you can see by using this statement x comma y comma z comma t is equal to symbols, we can declare these variable. Okay, and k, m, and g, these are the integers. Okay, this part is same as we use in the above added space, but we want to declare this as integer. And also we are required some functions FGH we are using. So to declare the functions we are using here at this place, CLS means calculus is equal to function. So this we are using for the function. So this is the interface when you will open live shell. Okay, this is the SymPy live shell. Now see the power of the this computing tool. See where you can give the inputs. This shell where you can give any input. So what I am doing now, I copy this statement, this one. I copy this one and come to here. This is the first example, just I copy and paste here, I will enter. So when I will enter, you can see the derivative of cos x with x. With respect to x, we have is minus sin x. Just you are required to click on it, and frequently this will return the output value. So this is the function diff. Diff is used here for differentiation, and this will be used for both, whether it is a partial derivative or ODE. For both we will use, and for all type of the higher order also. Okay, just like if you want to take here second order, so what you will do, you will use here comma and x. So this is the second order derivative. If you are required here third order, okay, then you will increase here one more x. So this is the third order derivative. What idea? If you need fourth order, you will increase one more. Okay, but I need 15th order derivative. Okay, so this process will be very long. What I will do, I will do like in this way. If you need fourth order, just use here 4. So this is also the fourth order derivative. Sorry. Okay. Sorry. Yes. So this is the fourth order derivative. So the value of this one and that of this one both are same, cos x. Okay. So if you need, here you can see the one more example here. Okay. You can take this example also. Okay, this is the this is exponential function and of x square. Its derivative with respect to x we have is 2x e raised to power x square. Okay, if you need third order of this function, by pressing the upward key from your desktop, you have the previous statement. I am using upward arrow sign, downward arrow sign. When I will press upward arrow sign, the previous statement will be there in this shell. If you need the third order derivative of this function, just type here 3. This will return the third order derivative. If you need here the 15th order derivative of this function, so this will return the 15th order derivative of this function. Okay, so you can see this is the 15th order derivative. Very long answer is there, you can find here. So within few seconds you will find the derivative of this function. So this is the answer to take the derivative of this function 15th order. So this is the power of computing when we have the large computing or the complex calculations. So with the help of the computing tool, we can have the answer within few seconds. Okay, so this is the very powerful tool which you can use without installation in your system. Okay, I am using now cloud based. So all type of the calculations which you need, you can do. Just see one more thing. I am taking here f is equal to suppose that I have the function sine x square plus y square, and here divide it by x plus y. Okay, so when I will enter f, okay, x square is missing, square is missing. Got it? Yeah. So if I will enter again f, sorry, If I'm entering here f and enter, this is the function sine x square plus y square upon x plus y. So this is the symbolic expression, and this can be possible by using SimPy. Here you can see. Okay, if you want to apply some more operations on this, so here f is a function of two variable. Okay, now when I will apply diff function for this one, how I can do f comma x. So the meaning of this expression is partial derivative of f with respect to x, and this is the answer. If I want to use here y, so this is the partial derivative of f with respect to y, and you can see the difference in both the answer. Okay, very simple. If you want to use here x comma y, so this is the partial derivative of f, second order partial derivative of f with respect to x and with respect to y. Okay, so this is the second order partial derivative. If you wanted to take the partial derivative with respect to x two times, okay, so this is the partial derivative of f with respect to x second order. And if you need with respect to y second order, okay, very frequently you can see all the results. Just you need to give the input and immediately you have the answer. Okay, if you are required some higher order, suppose I need partial derivative of x five times, okay, and with respect to y I need three times. See the answer. This will be very long answer. This is very long answer because we have 8 order derivative. Okay, you can see the answer is very long, but time taken is very less. Okay, this is a very long answer which you give the input at the place because the function is also second order and in fraction. Okay, so when you will apply this operation, you can see the answer. Got the idea? So these are very simple to use. Just you should have this tool and pick the formula, how you can use it for the basic concept, how you can use the examples are there. Various examples are given here to use in a different way. Okay, see this one also. See this function. Okay, I am copying from this place and I am trying to use here. But this is a different way to use. Here we have the derivative function. Here we have is the derivative function. But in the place of expression, I am using here our f function. Okay, we are using f function. So here x, y, z, we don't have three variable. We have only two variable. We have only two variable. Enter. deriv. Enter. So we want to differentiate this expression. This is the second order. Okay, previously this expression was not appear, but by using this one, if you want to present the function in this form, you can use derivative. Okay, d is in here in uppercase. Just you are required to, as we are speaking, the syntax are same. Okay, so here if you want to differentiate it now, you have to use here derivative dot do it function. Do it. So when you will use here do it function, this will perform the operation which we have applied at the place. Okay, so this is the value which we have stored at the place. You can see on the right hand side. After that, we want to apply this operation. So for that you will use here do it function. So this is the variable, and on this variable we want to apply do it. The operation will be applied on this, and this will return the value, as you can see here. Okay, so if see here, you need x three times, okay, and y two times. See once again. So the meaning of this one is we are going to differentiate f with respect to x 3 times, y with respect to y 2 times. So the total partial derivative order we have is 5. Okay, total order is 5. Enter. Derive. This is a variable where we store the value, and see the expression. This is the fifth order partial derivative with respect to x3, with respect to y2. So if you want to do some next level, okay, what you will do, you will apply here do it. You will apply do it. So this do it will complete the process. This is the fifth order partial derivative of the function. Okay, so I think the examples which I present here are quite easy for you. Okay, so all the operations, all the examples here, you can manipulate them. You can choose your own example. Okay, and here you can see the operation do it. Okay, is applied here. Okay, so here are the examples of the integral. Okay, I am taking this example.
You have
I am taking this example. Any question, please? Do you have any question?
out of the 100 students, 10 pays for the course. So you've recovered the 3,000 naira. We're making another additional 20,000.
Asia, I am not getting your exact voice. Some echo is there. Your voice is not clear.
Completely in the general group, take note of the fact that they just type payment noted. And I also advise that once I advertise the course and I'm running my own advert, join my general group.
Sorry, Ish Muhammad. If possible, you can text me. Your voice is not clear to me. Please text me. Please text me in the chat box. Galaxy, most of the time system of differential equation are used for modeling. Yes, all the as you are Galaxy, you mentioned here. So all type of the mathematical modeling, you can use this tool. Okay, and I will try. Yes, this doesn't matter how many variables you are taking. Okay, I take here very simple example. You can choose 2 variable, 3 variable, 4 variable, 5 variable, 6 variable, because when you come to the up to 6 variable, so definitely there will be some parameters. Okay, so don't worry about the parameters and the variables. Everything which you need, you want to compute, you can do everything by using this tool. Okay, and these days for the quantum computing or mathematical modeling, many things are there. Okay, just you have to start this tool to work on it, clear the basic fundamental, then try to use in your domain. You can do. Okay, so easy to use as compared to this is as simple. Just you are using the MATLAB. Okay, so in the same way you can write your own code, and there are similarity between SymPy and MATLAB. So there is no big difference. Okay, Scilab, SymPy, and MATLAB. There is many things are similarity there. Okay, and SymPy, the toolbox, this library which I am asking now, we are presenting completely based on Python. The syntax which we are using, this is developed based on Python. So very simple to use. And in the previous session, you can see all the statements and the functions which we are trying to cover are quite easy. Okay. So here is also there no problem. Just you have to start to work on it and understand the basic concept. And after that, I will let you know how you can use this library to import in the Jupyter notebook. Also, we are going to cover there. Okay, so here some of the examples I try to present here. So similarly, you can use how you can use the integration. See here. So this is the syntax. Integrate cos. This is the function cosine x comma x. Okay, so this will integrate. You can have any function here. Just like if you are taking here sine function, you can change and enter. Okay, so this is the so in the place of f, you can have any function. Okay, you can do double integration, you can do triple integration, you can do definite integration. Okay, but remember that when you are doing indefinite integration by using any computing tool, the constant of integration will not be there. Just like you can see here, this is indefinite integral and there is no constant of integration. So when you will use any computing tool, so constant of integration will not be there. Okay. So if you want to for the definite integral, yes, you can see. This is the example of definite integration. See the symbol. Okay, integrate. This is the e raised to power minus x, and this is the limit of x variable 0 to infinity. So to write the infinity, you will use lowercase o 2 times. So this is the infinity. This is the lower limit. This is the upper limit of x. So see here, this is the way how you can use limit for definite integral. So when you will use and apply, you can see this is the answer. This will return the direct answer. Okay. And if you need, yes, you can see this is the double integration. Okay. So you can try how you can use the double integration. So this is the example to how you can use for the double or triple integration. Okay, so here you can see this is the function e raised to power minus x square minus y square, and this is the limit of x variable minus infinity to infinity. This is the limit of y minus infinity to infinity. Enter. Okay, this is the answer. So in this way, you there are various examples are there. You can try yourself, go to all the entire file. So all type of the calculations are there. Okay, this is the limit. These are the syntax, and their respective. This is the manual expression, and this expression can be written as this is the syntax how you will use, and this is the Python syntax. Okay, so all topics are covered here with their examples. This is the left limit and right limit. You can go through there here. If you are required to expand in the series form, you can do here. Finite difference are there. So these are the solvers. Sometime if you are required to solve the differential equations, you can see solving the equations algebraically. Okay, so if you have any question, any equation, you can solve here. If you need to solve the differential equation, so here you can have, yeah, you can see solving the differential equations. Examples are there. So you can try easily all these examples, these expressions. Okay, and this is the matrix topic. You can try all these expressions in this live SimPy. Okay, this link also I will share with you in the WhatsApp group. Okay, there is live SimPy. So this is all about the basic introduction about the SimPy library and how you can use live.sympy anywhere, whether you are using the laptop, and you can open the same in your mobile also. Okay, so demonstration I think is easy and interesting. If you have any question related to this library, please feel free to ask me. Okay, so you must cover all these things. This will help you, and you should start from basic operations. Okay, you should start just like we need to substitute the values, then we will get the answer. Just like we have the value of x is 0, so how you can substitute these values, how you can substitute the function, okay, and many more. Okay, just like you can see here this expression, and here x is equal to y, we substitute the value x is equal to y, so this function is converted into y. And if you have the x is equal to 0, this is the answer. So you can try all these topics: printing, simplification, calculus, solver, matrices, advanced topics are also there. Okay, then these are the physical science related topics are the bioinformatics, machine tutorial, mechanics, quantum mechanics. So various topics are there, control tutorial. So you can easily come to cover all this topic, because just what you need to understand only the syntax. Okay, and from this file all type of the syntax which you are required for scientific computing are there. So according to your domain, your interest, your field, you can pick one of them according to your need. Okay, so you must try to cover all this content which is available in the document file. Okay, so now I going to start from opening the Jupyter notebook. My Jupyter notebook is opening. Just 1 minute. My Anaconda was also shut down. I have to restart. Okay, no question. Yes, there are various applications of this SemPy and the other which we are using the SciPy. So both the tools are very useful for all type of the scientific reporting, or whether you are developing some mathematical model, machine learning. In the machine learning, actually, when you are working on the deep learning, in that case, we are required at many places partial differential equations, partial derivative. Okay, so if you are developing your own model, for that this SimPy will help you. Okay, just like d gradient. For d gradient, we have to take the partial derivative. Okay, just 1 minute. My Anaconda is opening. Okay, so I am going to share my screen again. This is yeah, this is my Jupyter notebook. Yes. So in the today's topic, files are in my download. I think this is the lecture. All the files which I have created are in my download directory. This file which I am opening now, SimPy and SciPy, both the libraries are there. Okay, so here we are using some numerical computing with SimPy, and the other file I have is this one. This is based on NumPy. Okay, so this file you can easily cover yourself. I will not spend time more time on this file. Okay, so many examples you have covered. Some of the examples you have covered, but some will be there, some advanced examples. Okay, so yes, my purpose is to cover this part. So here you are required to import both the libraries. One is SimPy is SP and NumPy is NP and SciPy. Okay, these three libraries are required. Okay, if you want to check the versions of all these three libraries, we can check their version just by using the statement. Okay, you can check version of any library if you are required. Just you are required to put the name of the library dot underscore version underscore. Similarly for the other libraries. Okay, so when I will execute this shell, control and enter. Okay, so NumPy I am using 2.3.5, SimPy I am using 1.14, and SciPy 1.16.3. Okay, so these are the versions of these libraries which are in my system with Anaconda. So here are these are the practical examples. Okay, so this is the variable which we define at a place. We are using two variable x and y. Okay, if you want to use some more, so actually we are using the SP means SimPy. Okay, SimPy. Okay, so SP is there. So with the help of SP, you can define the variable which you want to use. See this example, x comma y is equal to sp dot symbols x space y. Don't use here comma. only space. Okay, so these two variables has been used in the entire file. So this is the expression, just you can see x square plus 3x plus 2. So when I will execute, this is the x square plus 3x plus 2. Okay, so these parts are also there where I show you SimPy tutorials. Okay, all these examples are there. But here we are using in Jupyter notebook, but the use here is a little different. Okay, just you can see here only this one, and you have to required to import the libraries, and then after you can use. Then if this is the way how you can write polynomial. If you are required to expand this factor x plus 2 product x minus 5, sp dot expand is the function. This will expand this expression just like control and enter. You can see this is x square minus 3x minus 10. Okay, if you want to factorize, so just like you can see here x square minus 25, you can take anything at the place. This will do automatically everything for you. Sp dot factor is the function. Factor is the function which will do factors of any polynomial. Okay, so for the simplification there is a simplify function. For the simplification we have simplify. So here we have x square minus 1 upon x minus 1. Okay, so control and enter. So this is x plus 1 only. Here is, you can see, solve the equation. The meaning of this one is, you can see sp dot equation. This is the equation. So how you can write the equation here. So this is the left side of the equation, x square minus 9. This the right hand side is equal to 0. The meaning of at this place is x square minus 9 is equal to 0. You have this one, x square minus 9 is equal to 0. Okay, here when you want to solve, you will write, see the expression syntax, sp dot equation. Eq is used for equation, to write the equation. Okay, x square minus 9 is equal to 0. Okay, this is the equation. Then we apply here solve function. So there is a solve function in sp simpy. So this is solve function will solve the equation. When you will enter, you have the answer. There are two roots of this equation. Sometimes you have the simultaneous equation. Two equations are there and you want to solve. Okay, here you can see the symbols we have, and this is the first equation. We store the equation in eq1. Okay, this is the first equation. The equation is 2x plus y is equal to 8. The meaning of this expression is 2x plus y is equal to 8. And the meaning of this one is x minus y is equal to 1. Okay, so x minus y is the left side and 1 is right hand side of the equation. Okay, so we store these two equations in two variable, eq1, eq2. Now we are using the same function, sp dot solve, and put the equations here, eq1 and eq2. We want to solve these equations for x and y variable. For x and y variable. Control and enter. Control and enter. The value of x will be 3 and that of y we have is 2. Okay, so the same you can do by using the numpy, but way is different. But here the same equation we are solving by using the simpy, but the way is different. Okay, this is the practical example of differentiation. You can see here, this the x, the variable is x, and we have this expression. You can have any function at the place, and we wanted to differentiate this expression with respect to x. Okay, the same example you can use in simpy, but here when you will import the simpy in Jupyter notebook, you have to use sp. Then you can use this function diff. to differentiate. So all the operations which I present in SimPy live shell, you can do here, but you need to change this thing only. Other all the things are same. You can see here, control and enter. So the derivative of this expression we have is 3x square plus 10x plus 1. Similarly, if you want to take the second derivative, so this is the sine function. Now the sine function we are taking from SP, not numpy. Okay, when we using the numpy, in that case we have np at the place. But now we are using the library simpy. Okay, that's why we are using here SP. Control and enter. Okay, this is the second derivative of sine x with respect to x. This is the indefinite integral. See the same function. Same function is there. The difference is sp dot. This will do the integration of x square. You can use here any function. Okay. So all those examples which you try there. So these are the way how you can use for the integration. If you want to compute definite integration, we have this expression. We are using here x square, but the limit is x variable varies from for the interval 0 to x. Control and enter. 125.3. This is the exact solution because not in the float value. Okay, this is the symbolic expression. If this is in the float value, then that will be the approximate. But here, symbolic answer. Similarly, you can compute the limit of any function. This is the expression. Sp dot limit. This is the function. Sine x upon x and x equals to 0. 1. This is the Taylor series. You have studied the Taylor series. Sp dot series function x 0 to 6. Okay, 6 terms will be there. Okay. Then you can have the matrix. How you can write the matrix in by using the SP? See, SP dot matrix, SP dot matrix. Okay, M will be in the uppercase. And then this expression inside the parenthesis is same as we use in the case of numpy. And if you need the determinant, we have the same expression, a dot det determinant. So this is from, because we are using numpy. We are using numpy? Yes, you can see numpy. Okay, so here you can see where is determinant a dot dat. So this will compute the determinant, and this is the inverse. So if I will control and enter, so the determinant is -2 and inverse of a is, okay, this is also the same function which we use in numpy. So the partial, we have the same expression. Okay, you can see. And here is also the eigenvalues. What you will do, you are using in this way. This is the matrix and then dot eigenvalues. So you have to use function at this place. This is the syntax. As we are speaking, as we have at this place, we are using the same function. Okay, eigenvalues. So this will calculate the eigenvalues of this vector. Control and enter. Okay, so these are the eigenvalues. Jacobian, if you need to calculate the Jacobian, this is the expression. Jacobian for this matrix. Okay, control and enter. So I think you have studied about the Jacobian, you have studied about the numerical integration. Okay, so this is the lambda. Sometimes we are not able to integrate some functions, so you can use quad. Quad is there. Okay, so by using this one, you can have the numerical integration. So you have to import quad from functions which are not integrable. So we can use lambda x dot x square 0 to 5. So at the place you can have any value, any function. Okay, whether it is integrable or not integrable, but you need some numerical integration. So this is the way how you can use, how you can integrate. Okay. Then you can have the solve ODE. How you can solve that ODE? Okay, here we are using SymPy integrate import solve IVP. Okay, then we have the definition. We are writing the function here. Okay, this is the function. This is the function. Definition model t comma y return minus 2y. Okay, so this is the meaning is dt upon dy is equal to, we have this one, solve. Okay, so here we are using solve initial value problem. Okay, model is the function where we define the function here. Okay, this is the interval 0 to 5 and we want to compute at y. Okay, so 0 to y and 5. See, solve dot y, the answer. So this is the area of the solution. 5 points from this interval. 1, 2, 3, 4. Many values are there. Okay. The model which we write at the place we have is minus 2y. And its solution is in the form of array. Okay. Just 1 minute. 1 minute, please. Give me 1 minute.
Hello?
Hello, just 1 minute, please. 1 minute, 1 minute.
Okay, okay.
1 minute, please. Okay. Yes. So here we have the differential equation. I should mention here. This is dy upon dt is equal to minus 2y. Okay. And with the initial condition, y 0 is equal to 5 is equal to 5. Okay. And interval, this is the interval 0 to 5. So when you will, this is the given problem. Okay, so 0 to 5, we have to initialize from 0. Okay, so these values are we are given, and when you will apply, this is the model, and this is the way how you can apply. So this will solve for the y, and these are the values. So the solution will return in this in the array form. You can see here. Okay, so if you can visualize, if we can visualize the output of this expression, we can do, I have the code here, line space 0 to 5, and this is the exact solution which we got. The exact solution from this equation which you will get is this one. So you can use this statement. So here plt dot plot. So these are the this is the library. By using this library, you can visualize your result. This library which we are using here, we will cover in the coming sessions also, because here we are required to visualize the our result also. So this will help for the better understanding. Okay, so here this is the way how you can plot the value solution dot t and solution dot y0. Okay, and these are the marker. This is the label. Then plot. This is the exact solution. This is the plot of the exact solution. We have two solutions. One is by using the this way numerically, and other is the exact solution. Okay, this is the x label, y label, title, legend, grid on. Okay, and plt dot show. Control and enter. Yes, you can see the solution. Actually, the values which you can see here are numerically return in this form. But we have some problem to understand all these. So what you can do, we can visualize them. Okay, so what we have done here, we are using the numerical solution as well as the exact solution. Okay, so we can easily compare both. So this statement which you can see here, this is used for numerical solution which we get here. Okay, so all the solutions, all the values we have in this variable, and the other variable other is the exact solution. Exact solution is 5 into e raised to power minus 2t. This is the exact solution, but here we take the line space from 0 to 5. 0 to 5 we are given interval, so 100 is the number of the point in this interval. Okay, so as much you have the number of point in the interval, we have more more you can say the fit curve. Okay, if we have the less point, then this will be not fit the curve. So that's why we take 100 sometime depend upon our choice. how many points are required to plot exact solution. Okay, so here you can see the red color. The red color represents the approximate solution by using numerically. Okay, and the blue line is the exact solution. So both are similar. Similar solution is there. There is no difference whether you are using the numerically computing or you are using the manual. So when you need to find out the exact solution, we have to do either you will use the SimPy library with the help of all the solution will be symbolic solutions. Okay, or you will get the exact solution manual because the equation which we are using are very quite simple. Okay, after when you will do simple manually solution, so this will be 5 e raised to power minus 2t, and this is the line space which we have used here. Okay, so this will help you for better understanding. So this is the way how you can compute any differential equation. So many times we have solved various type of the equations, but we are not able to visualize. So without visualizing the solution, we don't have the exact a deep understanding about the what we are doing to solving after solving the differential equation, and what are the exact meaning of the solution. So this will help to understand and to deliver the content for the students also. Okay, so when you will visualize the solution of any kind of the differential equation or partial differential equation, so this by this we have the deep understanding about our solutions. Okay, by visualizing the results. So in this way we can integrate this part, how you can find out the numerical solutions and how you can visualize. So visualization part we will cover in the coming session by using 3 libraries we are using. One is matplotlib, just like we use at the base, matplotlib.pyplot as PLT. Then we have the next library will be the Seaborn and Plotly. So these 3 libraries are very essential for all the participants for different type of the visualizations. You got the idea? Okay, the same solution which we got at the base, we visualize these values through the by using this library, matplotlib. Okay, and you have the exact information. So here this is very awkward looking to understand. So here we have the some, if you are using some automation technique, so we have the SciPy dot optimized module is there, and from that you will import according to your need. So here we import minimize. Okay, so here we have the function, you can see lambda is equal to x square plus 4x plus 5, and we want to minimize f comma 0 dot x. Okay, so when you will f is the this function at 0 the value of x. Okay, minimum value. So this is the minimum value. If you want to find out the root, so this is the way root, then put the equation. This is the x square minus 16 is equal to 2 is equal to. Okay, so control and enter. This will solve for x. Here is the example of the curve fitting. If you are working on the curve fitting, you can use you can fit the curve, just like we have the x array, we have the y array. Okay, so this is important to import here from scipy.optimize import curve fit. So these are the 2 vectors, and by using these values of x and y, we will fit the curve. Okay, so we have to write here model x comma a, return ax. Then a is the parameter which is required to find out the value. Okay, x and a. So here curve. This is the way how you can fit the curve. So actually, if you will use here, you have x and y. Okay, x and y. See, first I will execute the same. Okay, 2. This is the value of this parameter. Okay, which is here. So after this is the value of a, which is we are required by using this value. Okay, so interpolation, we have the same. You can see scipy dot interpolate, import, inter pld. So this is the x vector and this is the y vector. So what is the interpolation? And what is the meaning of curve fitting? So all the above topic are quite simple, but curve fitting, what do you mean the curve fitting and interpolation? Can you please explain about this? Why we need interpolation and why we need curve fit? Anyone, please? Can you please anyone explain about this term? And what is the meaning of interpolation?
Is interpolation for?
I'm not getting voice from your side. Yes. Who will explain? Anyone from you?
So it is the process of finding a function which satisfies those set of points.
You are explaining about the curve fitting?
No, interpolation.
Interpolation. Okay.
So the function which satisfies exactly those points. That is, if the function is y equal to f of x, in the place of x, if we put one of the values, the exact y value should be obtained. But curve fitting, it's not necessary that all the points are satisfied, but majority of the points. That is when we
Okay.
draw the graph of that particular function, it should not be necessarily passing through all the points. But in the case of interpolation, it should be passing through each and every point given.
Okay. Okay. So see, I am sharing my screen again. Thank you. Yes. So for the curve fitting, so this is the process to find out the relationship between the variable. Okay, just like we have x and y, so we will have y is equal to some function of f x comma a. Okay, so just like you can have, for example, y is equal to mx. Okay, you have the value of y, you have the value of x. Okay, but you want to fit the curve. So m is some parameter. You are required to find out the value of this parameter. Okay, so you can have the linear, you can have the non-linear. So for the case of linear case, you can have two variables just like y equal to mx plus c. Okay, so depend upon the data set and the process. So here we put present the very simple example. So we are given x and y. Okay, so here is the a. So this value is required to find out. This is the value of a. Just like you can see, y is equal to f x a, to find out the relationship between these two variables, y and x, so that if you have the value of x that can be equal to y, by using the combination of x and a. Just like you can see, mx plus c make equal to y. So we are required to get the value of m and that of c also. Only then we can have y is equal to mx plus c. This is the linear curve fit. Okay, so by using this method, as you can see, curve fit is there, and by using this function, this will automatically do everything. Just we are required to use this statement. Okay, and you have to write the model. Okay, model means how many variables are there. If you want to use this one, then you have to write here x comma m comma c. Then you have to write the expression is we have on the right hand side. Okay, then you have to pass at the pace. This will automatically fit the curve. So you can try by choosing different examples from your side. Okay, and this will return the value at space. And if you want to verify, you can do. You put this value here. So this is a 2x. This is 2x. So if you want to verify, you can do. If x is equal to 1, then y equal to 2. If x equal to 2, then y equal to 4. Each values are twice here. Okay, so this is the curve fit. Got the idea? Similarly, for the interpolation, you have the value of x and that of y. Okay, and the values which you want to find out, unknown value, which lies between this range 1 to 4. Okay, you can see here we want to find out the value of 2.5 by using this data. See, control and enter. So when the value of x is 2.5, that of y will be 7.5. So this is the interpolate. Okay, this is the interpolation. Got the idea? So now we have FFT. Okay. So did you listen this term FFT? What is the FFT? Anyone?
Maybe fast Fourier transform.
Fast Fourier transform. Okay, so very simple here to compute the fast Fourier transform for this array. Okay, just you can see SciPy is very smart library. SciPy.fft import FFT. Okay, and this is the array. You can see np.array 1, 2, 3, 4. Okay, when you will enter, so you can see the output value. Fast Fourier transform of these values. Okay, but the thing is, sorry, I am not covering the basic fundamental of this topic. Okay, I am considering that but sometimes if we need, you can use. But in the entire data science and statistical analysis, we are not required this part because this is highly useful those people who are working in electrical science. Okay, if you need the distance, okay, Euclidean distance, so you can see SciPy, from the SciPy spatial, from that we are need distance formula and import Euclidean. Okay, this is the way how we can use these libraries. Okay, actually that depend upon our work. Okay, because these libraries are very vast. Okay, mathematics is very vast. So all the things we are not able to cover, but depend upon in which domain we want to work. So according to that, we have to pick the formulas, the tools, expressions, syntax, and how we can use. Just this session will help you how we can use these libraries. Okay, and what are the expressions. So this will help you in the coming sessions. Okay, not all, but fundamental must be clear, then will help you. So this is the answer. Okay, the distance between these 2 points. What is the sparse matrix? Anyone please? What is the sparse matrix? Anyone please?
Maybe a matrix with majority of the values zeros. I think so.
Any example please?
Elements zeros.
Example please.
Maybe in the whole matrix, very few non-zero elements and all other elements are zeros.
Okay.
Sure, I think so.
What are the application of the sparse matrix? Can you please let me know? I think you know about the application. May I know about your
Maybe
name? Your name,
Susan.
please.
Susan.
Uh, okay. Where are you working?
I'm working at St. Thomas College. It's in Pathanamthitta, Kerala. Kerala.
Kerala.
Kerala, sir.
Okay, great. Thank you, ma'am. Thank you. Kerala.
Okay.
Okay. Highest literacy rate in Kerala.
Yeah.
Okay, thank you. And how the sessions are going, ma'am? Okay. So here, according to madam, saying that the majority of the element will be 0. Okay. So yes, here you can see when I will execute. So can you please explain about this one? You can see here the CSR underscore matrix. I use this example. Okay, here the element are 005, then 2005. These are the elements of sparse matrix according to you say. Okay, here we use the CSR underscore matrix statement, and after applying this function, uh, we see here the shape is 2 by 3. Okay. There are 2 rows and 3 columns. So this is the sparse matrix. What is the meaning of this one? We can do in another way. If I am taking here C, this is the last example, okay? T test, okay. Only 2 examples are there. I will take only 5 to 10 minutes. Suppose it I am taking A is equal to np dot array, okay? Then there is in the first row, I have the values 5, 0, then 0, 0. So 4 zeros are there. Okay. This is the first row. Then I am taking the next row. The elements are, suppose I have 0, 0, 0, 2. This is the second row. Then I am taking third row. Okay. Actually, I never study about the sparse matrix. Okay, so I need help from your side. If you can give some clarity about the sparse matrix, let's we try it together. First time I'm using this example. 8, 0, 0. Is it okay, ma'am? This is the sparse matrix.
Yes, sir.
This is the, just a moment. According to,
Arrays.
we create this is the dense matrix. Dense matrix according to the theory from theory which is available at my place. According to that is this is the dense matrix. Okay, and if we want to convert convert to sparse matrix. Converted to sparse matrix. Okay. M is in uppercase. Okay. We have to use S is equal to the same function which we use above. Where is, yeah, this one. This one. Here is A. Here is A. This will convert into sparse matrix, then print S. See what happened. Okay. Control and enter. Array. Okay. Here is array Y is missing. Control and enter. Yes. Okay. So this is the matrix, and mostly all the values are 0. Okay. Then this is the dense matrix. Then we convert to sparse matrix. Okay. So after applying this operation, you can see these are the coordinate, these are the values 0, 0, 5, 1, 3, 2, 3, 0, 8. Okay. Now we need to understand this part. Compressed sparse row sparse matrix of data type integer, okay, with the 3 stored element and shape of 4 by 4 greater than. Coordinate values you can see here 0, 0, 5, 1, 3. I don't know from where we get the y3, 1, 3, 2, and 3, 0, 8. Okay. So when we convert in the sparse matrix, we have this information. Got the idea?
Sir, Google says dense matrix means a matrix with majority non-zero elements, and sparse matrix is the reverse one, majority are zeros.
Majorities are 0.
For sparse, it is majority zeros, and dense majority non-zeros.
Okay. Okay. So, dear participant, you got the idea about this example, because this sparse matrix I try to use first time, because I never use in my applications. This is not my area. Okay. I listen the term. There is a sparse matrix, but I never use. So first time I do experiment on this sparse matrix. So when we are using this is the dense matrix, and by using this function we have the sparse matrix, and this will convert in this way. Okay, so according to Suman madam, she is saying a majority of the zeros. Ma'am, please explain in detail if you can do. Suman madam, once one more time repeat the answer. What is the
Sir,
sparse matrix?
dense matrix means a matrix with majority non-zero values, and
Okay.
sparse matrix is a matrix with majority elements zeros. So
Okay,
this
okay.
particular function, it compresses the data to only keep track of non-zero values. That is the application of that particular function. That is compressed sparse row matrix. That is the expansion of that CSR in that.
Okay.
Compressed
Thank you, ma'am.
sparse row matrix function.
Thank you, ma'am. Thank you. So, dear participant, if you have any question related to this sparse matrix, okay, because this is the new term, and I hope that the question which I want to clear, and the same is clear to all of the participants. So this is the t-test. Okay, the static part we will cover in the coming session when we have the statistical analysis. Okay, but if you want to apply the t-test, so there are various tests are required when we have the hypothesis topic when we will cover in the coming days. So this part will also will be there, but here is the example. Okay, from scipy.state import. This is the way how you can use scipy.state. Okay, and we are given two group. Here is the comparison between the two group. Group 1 and group 2 both have the same length, and this is the function, and by using this function we can compare these two, group 1 and group 2. So when you will execute, so what this will return? Okay, this will return one thing is statistic. Okay, the value you can see here 4 point something. Okay, this is the t-test value, and along with we have the p-value. P-value means probability value. This value is very essential, and by using this one we will be able to decide
So what will be the
whether
output for compressed field?
the hypothesis which we are applying here is uh, accept or reject. So this p-value is very essential. This is the only the static value. We will cover this part when we have the session on hypothesis testing in very detail. Okay, so when you will apply for these two different group to study, okay, for the hypothesis test, okay, you can apply TT test. Okay, this is the TT test, how you can apply. So in the more detail, this part we will cover in the coming days. So we are required some information, some test conditions, and different ways are to apply depending upon the data set. Why we need this type of the test to check about the hypothesis. So when we cover this topic, then the other concept is like what is the meaning of p-value, what is the meaning of a statistic value. So this concept will be clear with example there. Okay, but here only the example is added here, how you can apply t-test. So dear participants, this is all about the today's session. If you have any question now, and these are some practical example which you can do yourself. Any question, please? Okay, thank you, dear participant, for joining today's session. And now I want to check system of the equation. Yes, one of the participants is asking, Galaxy, whether you have the system of the equation, whether you have the system of the differential equation, all type of the solutions which you need for your scientific study, you can apply. You can use this SciPy and SimPy. Okay, but actually the thing is some practice is required. Also, if you want to develop for you want to use for the fractional calculus, yes, some of the operations you can do by using by writing user defined functions. You can do some fractional differential equation and their expression, everything which you need. Okay, so as you are using the MATLAB, and all type of the computing are possible there in the SimPy and SciPy. You can use these libraries for any scientific computing. So this was the some demonstration about the today's session, how you can use these libraries for very complex computing. These libraries will help you in the coming sessions and in the future use also. Okay. Any more
Yes,
question,
Professor.
please?
Yes, Professor.
Yeah.
Yeah, such kind of problems are very difficult for me in order to calculate the endemic equilibrium. So if you have time, please forward the syntax.
Yes, we can discuss. We can discuss. I know you are trying to catch me since last 2 weeks. So these days I am quite busy. But if you have specific problem, you can share with me on the WhatsApp. Okay.
Okay.
So
Okay. Thank you.
yeah, that is your research work. I know.
Yeah, such kind of problems are tricky.
Okay.
Okay. Thank
Yes.
you.
So you mentioned here three equations are there. Uh, okay, and you want to solve these. Yes, you can. If you are using the MATLAB, we can easily find out the solution of these problem. Okay, these are the equations from the CSIR model, SAR model.
Yeah. Yes. Yes.
Yeah.
Not
Yes, we can. Yes, we can
SSR.
find. In the
Yeah.
MATLAB, we
Specific
can do
variables.
easily. Yeah, in MATLAB, we can do easily.
Okay.
Yeah.
By any means, share me if you have time. Not
Yeah.
for today.
Yes, 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 yes.
So
And
today lesson is very interesting. I am attending via my cell phone using data.
hmm,
This is because of how your lecture is interesting.
okay.
Thank you very much.
Thank you. Thank you.
Okay.
Yes. So, dear participant, thank you very much for the session and your questions and answers. And I hope that the content which I tried to present will help you. So now I request to Phase, please conclude the session.
Yes, sir.
Are you there? Yeah.
Yes.
Yes, please.
As we conclude today's practical session, I would like to extend my sincere gratitude to Dr. Meherchand for his insightful guidance and hands-on demonstration of numerical computing using Python and NumPy. Today's session provided us with the opportunity to apply the concepts we have learned in previous lecture to solve real-world scientific and engineering problems. I encourage everyone to revisit today's exercises, experiment with different data sets in competition, and continue practicing independently. I would also like to thank all participants for your active participation, enthusiasm, and your willingness to code along the session. Thank you all for joining us today. Have a wonderful night, and we look forward to seeing you in the next session.
Thanks, dear participant. Good night. The content which I present today, the files are available in your WhatsApp group. You can access from that place. Thank you and good night.